Welcome to the video on hyperbolas. This is live with my 7th period class. Yay, my 7th period. Okay, all right. So we want to look at hyperbolas. So we heard yesterday, we looked at a video, right? And this gentleman was saying, there's this silly little box. And why do we have this silly little box? Well, this silly little box helps us find our asymptotes. And the asymptotes help guide our hyperbola. So we need only one point with our hyperbola, our vertex, and then we have to approach our asymptotes. So we need to first develop this box. And this box is found by going on the y, we go 4 up and 4 down, because y is the axis, the y-axis. So we go 4 up, 4 down. So over here we shift 4 up, put a point, 4 down, put a point. On the x-axis, we're going to go right 5 and left 5. Are we okay with that? Yeah? Okay. So we go right 5 and left 5, and that gives us our box. When we go right 5 and left 5 and up 4 and down 4, we get that box. Now, the asymptotes go through the corners of those boxes. And it goes through the origin. So, our vertices, though, this is where it opens. We want to circle. I always circle the first one. If you don't want to circle it, that's fine. But notice how this number right here, this 25, is larger than the 16. And it used to be the larger number that told us where our vertices were. But really now, it's the first term. All right. What else? Anything else? Our foci. How do we find our foci? Well, our foci are going to be the largest distance away from the origin. So this distance right here is our c value, and our c squared equals a squared plus b squared. So c squared, we want to find this distance. We know this distance here, and we know that distance there. So if we take 16, square it, 25 and square it. I'm sorry, I just said that totally wrong. Did my students hear it and correct my mistake? What did I just say? I said take 16 and square it and 25 and square it. Woo! Thank you, Jamie. Yes. It's already squared. It's already squared. 16 is 4 squared. 25 is 5 squared. All right. All right, Ben, what's your question?
Alright, well, I understand that the way you make the box is that you square root the number underneath the y and the x, and that's how you find the width and the height.
Yes.
But how would you then find the parabola after that? The actual, like, U-shaped type thing.
Good question. Thank you, Ben, for asking. All right, so that box helps us get these asymptotes, and the asymptotes is the line that our graph approaches. So we know that our vertices are going to be on the y-axis. We put that one point, and then we approach the asymptote that we drew from that box.
So from, like, the center of the box to the vertex? Like, midpoint?
Correct. Yes. Good. Here we go. So my students have this as a worksheet, and you should have, hopefully we did this in class already. If you weren't in class, you didn't get this. But we definitely want to find these distances right here. On the y-axis, we want to find this distance, and that's going to go underneath my y value. My y squared, I'm going to put 9. Under my x squared, I'm going to put this value squared. But I need to decide which one's going to come first. It's not the bigger one that comes first. Who can tell me which one comes first? How do I decide which one's going to come first? Yeah, Anton?
It's the one where the hyperbolas are opening on that axis.
Great. So on the y-axis, oh, sorry, here, this one we're on the x. On the x-axis, it's opening. So the x squared value goes first. Thank you, Anton. Very good. All right. What about number 2? Can we write the equation for that real quick? I'm going to pause. You guys hit pause. Try it on your own if you haven't tried it yet. And then hit play, and the answer will be here. My 7th period, who soon is going to shout out to Haley over in Israel. You'll get your answer.